Hello everyone, myself Dr. Kumala, working as Associate Professor in the Department of ECE, would like to explain about the rectifiers, the type of rectifiers and advantages and disadvantages of rectifiers. In the earlier videos we have learned about the diode, the working of a diode, the forward and reverse cuts of a diode. So in continuation with that, we are now learning about one of the major applications of a diode which we find in rectifiers. So first of all, let us learn what is a rectifier. A rectifier is an electrical device which is composed of one or more diodes and which can convert an alternating current into DC current. So in the waveform you can see that this is the alternating current which conducts in positive off cycle as negative off cycle, and the DC output is the direct current output voltage which is available at the output. The rectifier is one of the most important applications for diode, which is very much helpful in conversion of a sinusoidal AC waveform into a single polarity off cycle or as a DC output voltage. A rectification can be performed by two means. One is the off-wave rectification or as the full-wave rectification circuits. So here a DC power supply converts a sinusoidal AC supply to DC by rectification and filtering. The filtering process normally involves the use of large reservoir capacitor which charges to the peak input voltage level to produce the DC output, and the capacitor partially discharges between peak of the rectified waveform and the results in the ripple voltage of the output. So the ripples can be reduced by the use of RC and LC filters. So let us now first learn about the off-wave rectifier. So what is a off-wave rectifier? A off-wave rectifier is the one which helps in the process of removing one off of the input signal to establish a DC level, which is called off-wave rectification. In a off-wave rectifier, the rectifier will conduct current during positive off cycle of the input AC signal only, whereas the negative off cycle is completely suppressed. So here we have the circuit diagram of a rectifier circuit where a single diode is used in the off-wave rectifier. Here an input alternating input voltage is applied via a transformer. This is the diode which is connected in forward bias condition, and this is a transformer which is connected to a single diode in series with a load resistor RL. The transformer is normally necessary to de-isolate the rectifier circuit from the AC supply. The diode is forward biased during the positive off cycle of the input waveform and reverse biased during the negative off cycle of the input waveform. The substantial current flows through the load resistor RL only during the positive off cycle of the input. So, for the duration of the negative off cycle, the diode behaves almost as an open switch, and therefore the output voltage waveform will be developed across the load resistor RL, which is in series of the positive off cycle of the alternating voltage, but intervening very small negative voltage levels produced by the diode reverse current voltage. So here we can see that this is the input AC voltage, which is the alternating current from the AC supply, and here we see that the diode conduction is allowed in the forward bias condition and during the positive cycle of the input signal. So the AC input is converted into DC output. We have only positive off cycle of the voltage. So coming for the operation of the off-wave rectifier in brief, the OC voltage is applied across the secondary terminals of the transformer, which changes its polarity after each cycle, and during negative off cycle the terminal A is negative, and so the diode is reverse bias and will conduct no current. So the current flow through the diode is only during positive off cycles, and in this way the current flows through the load resistor in only one direction. Coming for the output frequency of a off-wave rectifier. If I take an example of a single sine wave, which is an input AC signal, which is conducting from 0 to 360 degrees, the output is only of it, which is 180 degrees. As the diode conducts in only positive cycle. So this waveform justifies that when input AC completes one cycle, the rectified wave also completes one cycle. So F out equals to F in a off-wave rectifier. Coming for the advantages and disadvantages of a off-wave rectifier. The main advantage of a off-wave rectifier is it is very simple and consumes less cost. The main disadvantage of a rectifier is the pulsating current in the output signal contains an AC component where the frequency will be equal to the supply frequency. So whenever we are processing the output of a rectifier circuit, the filtering is very much essential. And the second disadvantage of off-wave rectifier is the AC supply delivers the power during off cycle only. So the output or the efficiency of a off-wave rectifier is low. These are the disadvantages of a off-wave rectifier. So to overcome this disadvantages of off-wave rectifier, we go for the design of a full-wave rectifier circuit so that we can enhance the output power of a rectifier or else the output DC voltage. So next, coming for the full wave rectifier. What is a full wave rectifier? A full wave rectifier is a circuit which allows the current flow through the load in the same direction for both the off cycle of the input AC signal. So how do we achieve this full signal or its maximum output power? Yes, by connecting two diodes which works alternatively. So for one off cycle, one diode supplies the current to the load, and for the next off cycle, the another diode will operate. So that from a full wave rectifier, we have the output which is obtained at negative off cycle as well as positive off cycle of the input AC signal. The main importance of getting this is the full wave rectifier will make use of a center tap transformer where the circuit will have two diodes and along with the center tap transformer. During positive off cycle, the diode D1 conducts, and during negative off cycle, the diode D2 conducts. And it can be seen that the current through the load resistor RL will be in the same direction for both the cycles. So this circuit of a full wave rectifier, where we can see that this is the AC input voltage, this is a center tap transformer, this center tap transformer, we have the two diodes D1 and D2. The load resistor is connected in between these diodes. In the center tap transformer, the center tap is connected to the load resistor, and the output waveform we can see that the diode D1 conducts during positive off cycle, the diode D2 conducts at negative off cycle. So we can see that at both, that is the positive off cycle as well as the negative off cycle of the input AC, the output DC is obtained. So due to which the efficiency or as the output power of a full wave rectifier is much more enhanced compared to a off wave rectifier. So what are the advantages and disadvantages of a full wave rectifier? The advantages of a full wave rectifier are it has higher rectifying efficiency than the off wave rectifier. So they can convert an AC to DC signal, AC signal to DC more efficiently. The second advantage of full wave rectifier is their low power loss because no voltage signal is wasted in the rectification process. And the third advantage is the output voltage center tap transformer which is used in a full wave rectifier will have low ripples compared to that of a off wave rectifier. So these are the advantages of full wave rectifier, due to which in most of the applications when we want to convert a AC signal into a DC signal, we make use of full wave rectifiers. So what is the main disadvantage of full wave rectifier? The main disadvantage or one of the most disadvantage of a full wave rectifier is making use of a central tap transformer. The central tap transformer is the one which is very expensive and it occupies more space when the circuit is connected. These are the two major disadvantages of a full wave rectifier. Making use of a center tap transformer which is more expensive, and second reason is as the center tap transformer is huge, the circuit occupies more space. The third type of rectifier which we have is a full wave bridge rectifier. So already you learnt about the off-wave rectifier and the full wave rectifier. In off-wave rectifier, we make use of a single diode, whereas in a full wave rectifier, we make use of two diodes along with the center tap transformer. Whereas in a full wave bridge rectifier, we make use of four diodes, which is connected in the form of a bridge. So a full wave bridge rectifier is a gas rectifier which makes use of four diodes arranged in the form of a bridge. So what's the main advantage and why do we make use of full wave bridge rectifier? Yes, the full wave bridge circuit will not require the special center tap transformer which was used in full wave rectifier. In a full wave bridge rectifier, the center tap transformer is replaced by the regular transformer where the single secondary winding will be connected to the one side of the diode bridge network and the other winding of the secondary terminal is connected to the load resistor which is kept on the other side. So by making use of a full wave bridge rectifier, we can overcome the disadvantages of a full wave rectifier where the high cost center tap transformer is avoided and meanwhile the complexity or the space occupied by the circuit is overcome. So now let's study the circuit. Let's learn the circuit of the full wave bridge rectifier. So here is circuit of a full wave bridge rectifier. Here you can see that it is making use of a regular transformer where the input AC is given to the primary winding of the transformer and the secondary of the transformer is connected to the bridge circuit, and we have the four diodes D1, D2, D3 and D4 which is connected in the form of a bridge, and we can see that the primary winding of the secondary is connected to one terminal of the bridge, whereas the other secondary is connected to the other form of the bridge to balance the bridge. and we take the output across the load resistor. So coming for the working of the full wave bridge rectifier. In a full wave bridge rectifier, the circuit consists of 4 diodes connected with their arrowhead symbols, all pointing towards the positive output terminals of the circuit. Here the diodes D1 and D2, which are in series, will be connected are connected in series, and the diode D3 and D4 also connected in series. The AC input terminals are at the junction D1 and D2 and at the junction D3 and D4. So these are the junctions which is formed, that is the junction between D1 and D2. This is the junction between D3 and D4. The AC input, the positive output terminal is at the cathodes of the diode, and the negative output is at the output of the another diodes. During the positive off cycle of the input voltage, the diodes D1 and D4 are in series with the load resistor, and the load current flows from the positive input terminal through the diode to the load resistor and then through the load resistor and the diode D4 back to the negative input terminal. During this time, the positive input terminals applied to the cathode of D2 and negative output is at the diode D2 anode. So the D2 is reverse biased during the positive off cycle of the input. Similarly, the diode D3 will have the negative input voltage at its anode and the positive output at its cathode terminal during the positive input off cycle, causing the diode D3 to be reverse biased. So it is seen that during both the positive off cycle of the input and the output terminal, polarity is always positive at the top of the load resistor and negative at the bottom. So both the positive and negative off cycle of the input are passed to the output, and negative off cycle is inverted so that the output is continuous series of positive off cycles of sinusoidal voltage. So the output frequency of a full wave rectifier is equal to the double of the input frequency. So here we can see that this is the AC input signal which is given at the primary of the transformer. At the load resistor, we can see that due to the conduction of the diodes D1 and D2, D3 and D4, we have the full wave DC signal. So this means that whenever the input AC completes one cycle, the rectified output completes two cycles. So in a full wave bridge rectifier, F out equals the twice F in. Hence the output frequency is equal to the twice of the input frequency, due to which we can find that the efficiency of a full wave rectifier is double that of the off wave rectifier. So in most of the rectifier applications or rectifier circuits, we will try to make use of the full wave bridge rectifier circuit compared to a off wave rectifier. The disadvantages and advantages of a full wave bridge rectifier. The first, the advantages of a bridge wave rectifier are it does not make use of a center tap transformer, and the second advantage is the output is twice than that of the center tap circuit. These are the two advantages. Coming for the disadvantages of a full wave bridge rectifier, it make use of 4 diodes instead of 2 diodes in of a full wave rectifier. And the second, it has disadvantages. The internal resistance voltage drop of a full wave bridge rectifier is twice than that of the center tap circuit, which is used in regular full wave rectifier. So these are the two minor disadvantages of a full wave bridge rectifier. So in nominal applications, we try to make use of a full wave rectifier compared to a full wave rectifier so that we can obtain maximum output DC power and also we can obtain maximum efficiency of a circuit. Thank you.